Hey guys, let's go over this one with angled projectiles here. So they tell us that we have a Vx, so a horizontal velocity of 8 meters per second, and let's go ahead and change this 29.4 to 30 meters per second so it works better with our approximating that g is 10 instead of 9.8. All right, so on here, let's start with the horizontals actually, because that's a little bit easier. If it's going 8 meters per second to the side, 1 second later, how fast is it going? Well, there's no acceleration horizontally, so it will still be going 8 meters per second to the side. And a second after that, still 8 meters per second to the side, and so on. The horizontal velocity will never change, so it will continue to go 8 meters per second to the side the entire time. Vertically, that's a different question because gravity is pulling down on you vertically. So it is going to take away 10 meters per second of speed each second. So 1 second later, we're not going 30, we're going 20. And 1 second after that, we've slowed down to 10 meters per second. And 1 second after that, we got 0 meters per second of vertical velocity. 1 second after that, we're down to -10, and then -20, and then -30 meters per second. So now let's use that information to solve some of these problems right here. So the first part says determine the displacement of the ball. So in order to do that, we actually need to do a few other things first. So remember that our initial y velocity is 30 meters per second. That means that we are only going to take 3 seconds to get to the peak. And that means that we will be in the air for a total of 6 seconds. 3 seconds up, 3 seconds down for a total of 6. That information is going to be useful as we go to solve some of these problems here. So the displacement of the ball, they mean horizontally. So how far does it go to the side? Well, that equation is your Vx times your t. So our Vx, if you remember from the front page, is 8 meters per second, and our time is our total time there. So that is 6 seconds. So that means our displacement is simply 8 times 6, or 42 meters, is how far, excuse me, we go to the side. The next question says, well, what about the height above the ground? That is a vertical question. That is using the fourth equation that says our vertical displacement is our initial y velocity, the fourth one says final y velocity times time minus 1/2 times our acceleration times our time squared. So there is no final velocity at the peak. That drops out to be 0. So then when we go to solve for our displacement, it will be minus 1/2 times the acceleration due to gravity, which is -10, times our time squared. Now be careful. This time is the time to the peak. So it's 3 seconds, not 6 seconds. So we'll square that there. 3 squared is 9, times 10 is 90. Half of that is 45, which means we will go up to a height of 45 at our maximum peak there. Next part here on this, it says for part C, find the final speed of the ball upon hitting the ground. This confuses some people. They don't mean actually after they've hit the ground, they mean in that infinitely small moment in time as you're striking the ground. So we know we're going 8 meters per second to the side, and we know at the end we were going 30 meters per second down. Again, if you're wondering where I got those numbers, it's from right here. 8 meters per second to the side, 30 meters per second downwards. So how do we find the overall speed? Well, then we've got to do the Pythagorean theorem there. So 8 squared plus 30 squared, take the square root of that, and you'll get about 31 meters per second. All right, now they're going to change things a little bit here, and they're going to say, suppose that the horizontal component of the initial velocity had been 13 meters per second, and that the vertical velocity had been unchanged. So in other words, we're going to change this 8 meters per second to 13 here, but we're going to leave the 30 alone. So we'll still be going up at 30. So the first thing they say is, how is this going to affect the time of flight? Well, it doesn't, because if you have the same initial y velocity, you're going to have the same time to the peak and the same total time as well. So that will not change. Next question, it says, what about the displacement of the ball? This will change because our equation is that our displacement is our x velocity times our time. Well, our x velocity did change. It is now, 13 instead of 8, so it's 13 meters per second times our time. Now remember, this time is the total time that it's in the air, so it's 6 seconds. So 13 times 6 there is 78 meters. This makes sense. We're going not quite twice as fast as we were before. We're going 8 and we went up to 13. So our distance here should be, not quite twice as much. So instead of 42, not quite 84, 78. That makes sense there. All right, next part, they say determine the height above the ground. Well, the thing is, if we have the same initial y velocity, then we're going to have the same time as we said before, which means the same delta y, the same height. That will not change. So even though we'll go farther to the side, we won't go any higher. And then it says find the speed upon hitting the ground. So we'll do this one just like we did before, except now we will have 13 as our sideways motion, and we will have 30 still as our vertical motion, so that when we go to get our overall hypotenuse here, it is basically, if you round off, 33 meters per second.